Hello, good evening. I just don't like to show everything in here, because I have promised that I'm going to um, give you a revision in engineering data analysis for those who are in the Saturday class because they don't have any time anymore to meet up with me. So here you go. I'm going to present to you the ed exam. So, mhm, window. I'm gonna share my screen, okay? Oh, hang on. Stop sharing. I want the whole window. Entire screen, if that is okay. Oh, hang on. I think the voice is not there. Let me present again. Stop share. Stop screen. Present. Share. Okay, entire screen, or is it just a window? Entire screen. Also share system audio. This is the one that I did not click a while ago, and this is my third time to do my recording. Be careful sharing screen audio. If you have a guest, they will hear themselves. Got it. Okay, fine. Can you see that one? But I want the whole. Okay, this one here. Can we do it? Uh, I'm gonna to stage. Oh, that's the reason. All right, let's see how it goes here. Oh, hang on. Hang on. I'll just check myself. Okay. Okay. Yeah, I think it's working. Isn't it? It's working, right? And I'm there at the corner. Oh, what happened? Right, so let's start. All right, let's start now. Right, so one of the tests that I will be giving you is multiple choice. It's 10 points. And here's the question. Blank is defined as a branch of science that deals with collection, presentation, organization, analysis, and interpretation of data. So you're going to choose from here. If your answer is descriptive statistics, then you're going to circle it. Okay. But of course, I'm not saying that this is the right answer. You have to refer from your notes about the definition of these words in here. Descriptive is you're going to describe it, and then you're describing, but of course there are methods, research methods that you'll be using to describe a thing. Inferential is more on reasoning, statistics, so you're going to collect reasons why it was so or why not, why it's not. And of course statistics is, that's it, the word that we are trying to describe in here. Right. I don't like to be discussing them and then um, it's leading to the answer. I'm still giving you a chance to do your research. You still have time though. Right. Number two, data collected from original source. So original source, you have some terms in here like secondary, primary, and discrete. Now, discrete data is something that you're going to hide. Okay, be discrete. If they say be discrete, you're going to reserve some information. You don't like to divulge them. everything. You have to preserve some information that you don't like to say, or you don't like everybody must know. Primary, so these are the ones that you do, especially in an experimental research. These are the data that you obtain by yourself. It's not coming from any record or whatnot, but for secondary, it's coming from record or some sources. So number three, these are numerical data. So numerical means numbers. So is it quantity? Is it quality? Or is it primary data? So if you say quantity, these are more on numbers, and quality means these are more texts. So we know that very well, isn't it? Okay. Number four, there's a situation in here where Sarah got some data from a website. It's not her who obtained the data. So is it secondary? Is it primary? Or is it secondary quantitative? Or secondary qualitative? Or primary quantitative? Now, number five says that Simon did an experiment measuring the length of a spring based on a force applied to stretch it. So, is it a secondary qualitative, secondary quantitative? Is it primary quantitative? Okay, so he did the experiment by himself. And what is he obtaining here? What data, or which data is he obtaining? Is it a secondary or primary data? Number six is a method of collecting data by asking questions face to face or through social media. So we did this already. You did it yourself. You obtained data from one source to the other, from one source to another, I should say. And did you do an experimental research before, or did you do a survey, or was it just an observation? So you have to choose from the three. If your answer is observation, then you have to circle. Okay. But I'm telling that's not the correct answer. Number seven, Alice conducted a survey in her class to find the month her classmates were born. So is month a number, or is month a text? And you choose from here. Is it secondary qualitative? Is it secondary quantitative? Or is it a primary qualitative? Right. Number eight. Which of the following diagrams would be a suitable option to display qualitative data? Is it a pie chart? Is it a bar graph, or a scatter graph? Okay, so bar graph, we know very well what a bar is. There are bars here like chocolate bars, yeah. Okay, is it a scatter graph? It's still in an x and y axis, but they are scattered like this. And then is it a pie chart? It's like pizza, right? It has all the percentages and all. So which one displays a qualitative data? Number nine, it's a subset of a population. Is it statistics? Is it a sample? Or is it people? So my example here is, for example, this is an island, and then there are some people inside, for example, yeah, there. And the total people in this island, and if these islets here are included as well, then the total population would be, or the total people would be the population. And how do you call each element inside the island? Is it statistics? Is it sample? Or is it people? Right. Number 10 is a complete group of individuals or objects considered for a survey. Is it random sample? Is it sample? Or is it population? So it's complete group. Okay. Now for test two, which is 5 points each column, and this is defined from here, you're going to compute for the difference between O and E, which is designated by the column with the title of O minus E. Compute for that. Compute for the square of O minus E, and compute for chi-square. And then compare chi-square from this table here. But first off, you have to fill in 1, 2, 3, 4, 5, 6, 7. for that column, you do the same for the next column, you do the same for the next column. Okay, you don't need to do this one, the ones in yellow. No and no and no. All right, so don't do this. Hang on. Okay, don't do this, don't do this, don't do that. Okay, it's just the 7. 7. 1, 2, 3, 4, 5, 6, 7. So 7 rows and 3 columns. Okay, right. What shall you do in here? Then you do an O minus E. O is the observed data and E is the expected. So O is 290 and expected is 246. So you do, in your calculator, you do 290 minus 246, then you get 44. Okay, so let's write 44 in here. Hang on. Let's just rub that off in time. It's 44. And if you square 44 square, you get 1936. And then 1936 divided by E, which is expected, then divided by 246, that would be 7.8, sorry for that, 7.8699 or 7.870. And then you continue. You have to do the same to this row and to this row and to this row and to this row and to this row, except the ones in yellow. All right. When done, then you have 1, 2, 3, 4, 5, 6, 7 numbers on this column, the one I'm circling. You have to add them all up. Okay, why? Because the summation of O minus E squared divided by E observed minus the expected square divided by expected, from I is equal to 1 to I is equal to N. So when I is equal to 1 up to 7, then whatever is the sum, this is your chi-square. Whatever you get here, you have to compare to these values here. Now, using the table below, what is the critical value at 0.05 with a degree of freedom equal to 7? So what is 0.05? That is a percentage error. 0.05 times 100, that will be 5% allowable error. 0.01 times 100 is 1% allowable error. 0.001 times 100 is equal to 0.1% allowable error. If I may choose which one will I use, of course, I will prefer the 5% allowable error, because 0.1 and 1% are already approximately perfect. And it's so difficult to get that in statistics. So 5% is better than 1% or less. Okay, so if you're going to look at this table here, what is the critical value at 0.05? So this will be the column of 0.05, and this will be the column of 0.05 as well, with a degree of freedom of equal to 7. So I'm not going to get the 7 that will be in your test. I'm going to get with a degree of freedom, which is 5, for example. So the critical value of chi at 5, at degrees of freedom 5, is equal to 11.070. Okay, so sorry for that. Now, test 5 says compute for chi-square value. What is this? The chi-square value is the summation of all those I have encircled. There are seven values altogether. So if you have computed the sum, then you get a chi-square, for example, 12.5. Okay, I'll put three decimal places there, so I replace the rest with 0. So if the chi-square is 12.5 and your critical value is 11.07, 11.07 is less than 12.070. Then this one means you're going to reject the hypothesis. But if 11.070 is greater than whatever is the value of the chi-square that you have completed, then what's this? What's that? All right, sorry for that. Let's go back there. Where am I now? Oh dear. Sorry. Sorry. It should be this one. I'm sharing my screen. What happened? Because all of a sudden we have this film that Bursal vlog. What's that? No. I didn't know that person. So I'll go to here. Hang on. Here. All right. So if 11.07, sorry for that, is greater than the chi-square, then you say you have to accept greater than the critical value. Why is it that you're going to reject 11.07? Sorry, why do you have to reject the 12.0? Um, hang on, what am I saying here? Hang on. 12, your chi-square, I repeat, your chi-square is 12.500. That's the one you have computed. This is greater than the table 11.070. So you have to accept. Sorry for that. You have to accept. I got lost there. Okay. Accept it. Okay. The color is not good. Okay, but if the chi-square that you have computed is equal to 10.500, this is less than 11.070, then it means you have to reject. Okay, reject it. Why? Because it's towards the critical value 11.07. Okay, but if it's greater, then you are out of the critical value, so you have to accept. Okay, right. So doing that, then you will be finishing test 6 and you have completed 40 points. From here is already 40 points. You still have 5 points on probability. So in here, you have 5 scores of students, and these are the percentage marks. And for example, the question says, what's the probability that the score or the percentage marks is less than 70%? Percentage of marks 70%. How many are there? So you have less than 70, 69, 68. That's it. So the answer will be 2 out of 5. 1, 2, 3, 4, 5. There are two that are less than 70. What if it asks you the probability of percentage of marks greater than 70%? So you'll have greater than 70, you have 1, 2, and 3. So the answer will be 3/5. Okay. Next, two coins are tossed once, write a sample space. So I'm going to give you, say, one coin only. One coin tossed once. So that will be, the sample space will be, it's either a head or it can be a tail. What if two coins tossed once? Then the sample space of the two coins will be, it can be head for one coin and head on the other, or it could be tailed on one coin and tail on the other, and then you continue. You just have to separate them with comma. All right, so that's it. End of test. And I hope you have understood what I had explained to you. You can just go through this video every now and then until you will have your exam. Okay, so this will be a good revision notes for you. Thanks a lot and have a great day. Bye bye.